Okay, we're going to start the Redox chapter, Oxidation Reduction, with a slightly shorter video, an introduction video. We're going to jump around the chapter just a little bit to get you interested in the types of things we're going to be looking at, getting you an idea of what types of reactions will be taking place. Okay, oxidation reduction, redox. We all remember oxidation as, what is it? Oxidation is loss of electrons, right? Something becomes more positively charged. Reduction, gain of electrons. But when you deal with organic molecules, keeping track of electrons being lost or gained is not always the easiest thing to do. So we've got new definitions of oxidation and reduction that help us see if electrons are lost or electrons are gained. And so in general, when you're looking at organic chemistry, oxidation occurs when you increase the number of CZ bonds, where Z is an atom more electronegative than carbon. So if you add a nitrogen to a carbon, or you make a carbon-oxygen bond or a carbon-chlorine bond, you've added an atom more electronegative than carbon to a carbon, then that is an oxidation. Okay. Another way to look at oxidation is the decrease of CH bonds. So if you got rid of a hydrogen on an oxygen, or excuse me, got rid of a hydrogen on a carbon and put an oxygen on instead, note, you've decreased the number of hydrogens, you've increased the electronegative atom bonded to carbon by adding that oxygen. That's an oxidation process. Reduction is the opposite, and normally we consider reduction to be the gain of carbon-hydrogen bonds. So if you get rid of a more electronegative atom and add a hydrogen back on, that's reduction. Adding hydrogens is a reduction reaction. And while these definitions are kind of different than what you've known, they're just a nice way of showing you what's going to happen. It turns out if you add a hydrogen to a carbon, you are actually adding electrons to that carbon. If you get rid of an oxygen and put on a hydrogen instead, you are adding electrons to that carbon. Okay. So, note, if two carbon atoms change the number of CZ or CH bonds, you must look at the net change to see if that molecule actually got oxidized or reduced. For example, if you had carbon triple bond carbon and you converted that to an alkene, you had this alkyne converted to an alkene, note we've added H2. We've added two hydrogens on there to both carbons. That's reduction. We've added hydrogens. But look at this. If you had this molecule, this alkene, and you add HCl across the double bond, an H goes on this carbon, a chlorine goes on this carbon. Well, an H going on this carbon, we've added hydrogen to this carbon. That looks like reduction. But we added chlorine to this carbon, and chlorine is more electronegative, and so that looks like oxidation. So we say this is not a redox reaction, because this molecule didn't get oxidized or reduced. Yeah, we gained a hydrogen, but we also gained a chlorine, and so that's neither oxidation or reduction, whereas this is definitely, we added two hydrogens, definitely reduction. The general scheme that we're going to be paying a lot of attention to in the next video, because it is very, very important, is like this. If you've got a carbon that is saturated with hydrogens, holding all these hydrogens here, that is the most reduced form of carbon. Recall, reduction's adding hydrogens. You cannot add any more hydrogens to that carbon. So alkanes are the most reduced form of organic compounds. If you were somehow to take off this hydrogen and put an OH on there, that would be an oxidation, because you got rid of this hydrogen and put on this Z, this more electronegative atom, on that carbon. Note that going from an alkane to an alcohol is not an easy, nice one-step process. That's going to involve reactions from the next chapter, the radical reactions and all sorts of craziness to get this. So alkane to alcohol is not something people commonly do. It can be done though. All right, but note we've added one CZ bond. Note Let's add another CZ bond. If we made a carbon-oxygen double bond, yeah, we've added an extra bond here. Note this had 3 hydrogens, this now has 2. So alcohols are more reduced than ketones. Ketones are more, and aldehydes, ketones and aldehydes are more oxidized than alcohols. Well, let's add a third oxygen here if we wanted to. Let's put an OH on there, make it carboxylic acid. So carboxylic acids are more oxidized than aldehydes and ketones. And if we wanted to add another Z bond, if we've got 3 bonds to oxygen, the only way to do it is carbon dioxide. And carbon dioxide is the most oxidized form of carbon. It's got 4 bonds to oxygen. You can't get much more oxidized than that. All right, let's look at some of the reagents, the common reagents that get involved with oxidation and reduction. We'll look at the reducing agents first. Well, H2 is a reducing agent. As we saw before, we added hydrogen across that triple bond to make a double bond, added H2. So there's one way you can add H2 to molecules to reduce the molecule, and it's going to take a solid metal catalyst. Rare, but there's an instance where we need it. Dissolving metal reduction. You take sodium in ammonia, usually liquid ammonia, and this sodium dissolves in this liquid ammonia and has the effect of, when the sodium dissolves, it wants to be sodium cations and has 2 electrons, and you go through all this process here, and you eventually make hydride, which are 2 H pluses, and the 2 electrons become H2. So dissolving metal reduction is a way to make H2 that then can get added to your molecules. This isn't done very often, but we're going to show you where it is done. Most common ways of doing it, I would say the second most common way of reduction is H2 with metal catalyst. The most common way, the one we're going to do most of the time, in fact you have already done it when you did the chromatography lab and you had the fluorinone that you reduced to fluorinol, you use sodium borohydride, NaBH4. That's a very common reducing agent, as well as lithium aluminum hydride, LiAlH4. Get to know those 2 reagents. They are used quite a lot in organic chemistry. So those are our normal reducing agents. I'll skip forward in the chapter a little bit to look at our normal oxidizing agents. And here they are. Our normal oxidizing agents, there are 2 types. One contain an oxygen-oxygen bond. So O2, a very nice oxidizing agent. Back in grad school, I did labs where in order to oxidize my things, I just blew air through them. Just the room air, just bubbled it through it, and that oxidized things. Ozone, a very nice oxidizing agent. H2O2, hydrogen peroxide, has an OO bond, oxidizing agent. And here's another peroxide, tert-butyl peroxyacid here. Here's some other stuff right here. These peroxyacids like RCO3H, where you've got an R group, a carbon double bond oxygen, another oxygen, another oxygen, and then a hydrogen. Yeah, you'd think it was a carboxylic acid if there was an H right here, but no, there's another oxygen and an H. It's a peroxyacid, very nice oxidizing agent. Other common oxidizing agents when you have metal-oxygen bonds, potassium dichromate. Got all those that metal with those oxygens. That's chromium in the 6+ oxidation state. That's the maximum, and let's face it, most toxic form of chromium, a very strong oxidizing agent. You get potassium dichromate on you, and it will oxidize you. All right, chromium oxide, also chromium in the 6+ oxidation state. Potassium permanganate, we got a 7+ charged manganese there. That's nasty stuff. Potassium permanganate solutions dissolve gold. OSO4, that's osmium in the +8 oxidation state. Super, super awesome oxidizing agent. Super, super toxic oxidizing agent. I wouldn't use that unless I had to. And of course, I would follow all of the safety rules, and so I would be okay. How would you be? I don't know. Do you follow safety rules? You better. So that's our introduction to redox. We're now going to look at, in the next video, a nice redox scheme going between some of these different functional groups. And this redox scheme will be very important for you.